Welcome back to my YouTube videos. Let's talk a little bit about factoring polynomials. This is probably one of the most critical topics, but one of the most driest topics in all of algebra. It gives people a lot of trouble. Now, you might recall that 21 has two factors that aren't one in itself. So basically what we're just talking about is the process of taking a value and breaking it down into factors. Now, when things get a little dicey is when we take this whole situation and we move over to expressions. Like, for instance, consider the case of 4x minus 8. Or actually better yet, no, 4x minus 8. To keep things simple, make sure you realize that what we're really doing is we're going to revert back to a distributive property expression from what's called a binomial. See, this is a binomial, but what we want to do is we want to make this a product. Now, what you're going to do is realize that this is 4 times x, and 8 can be written as 4 times 2. Now, a lot of you will write this and a lot of you won't. But it is a distributive property expression because both terms have 4 in common. And 4 happens to be the greatest common factor. So that's going to lead to 4 parentheses x minus 2. And this is your product. And it's a distributive property expression. Now, they get a little more complicated. This is one you're probably going to see on your homework. Now, when you get into these power situations, they not only have a 3 in common, because 6 is 3 times 2 and 3 is 3 times 1. They also have a y in common. So 3 times y minus 3 times 2 times y. That's going to lead to a situation where if I want to write, once again, this is a binomial, but if I want to write this as a distributive property, they both have 3 in common and a y in common. So I'm going to write this as 3y times the 2 terms times the terms that I have remaining, which is y and negative 2. And now I'm getting very colorful. And once again, that's a distributive property expression, and that's factored form. And that's another thing we like to call these. And you're going to find out there's situations where you need to be in factored form, and then there's other situations where you need to be in not factored form. I don't know if you can see me or not. Now, we were running into some really complicated things on the assignment today. Like, for instance, something like this came up because they thought it was cute. This thing really has very little relevance in real life, except it's a lesson on how to factor a polynomial. Now, it's going to take a little bit of work, but what you're going to realize is that the x to the 5th is actually the greatest common factor of the variables. And I can actually write all of the terms in regards to x to the 5th. Now, follow carefully what I just did. See, there's other rules in regards to adding exponents. And therefore, you'll see that x to the 7th factors into x squared times x to the 5th. And x to the 6th factors into x times x to the 5th. Now they also have a 4 in common because 4 times 2, and I'm just going to write everything factored. And yes, it's going to take steps until you understand what's going on. And once again, just one of those topics we neglect a lot. You can rewrite the 8 as 4 times 2, the 12 as 4 times 3, and the 16 as 4 times 4. Now, after you write that, then you can go ahead and pull out the 4 and pull out the x to the 5th. So everything that I just underlined is the GCF. And in this case, the GCF is pretty complicated. So that's going to become 4x to the 5th. And then everything that I didn't underline stays in. And I'm just running out of colors. I'm going to get 2x squared. I'm going to get 3x, negative 3x, because you have to keep the minus, and then you got to keep a plus 4. So that last situation on the bottom, that is factored form. And I'm doing the best I can writing with my finger. Finally, it's about the best I can offer right now, because I also want to keep these videos short. You are going to run into situations where you might have to factor out a negative. Like, for instance, this is one of those x plus h situations you've seen. But let's say you're not very comfortable writing it with 3 negatives. You need to keep a negative outside of all of that. Since they all have a negative in common, you could write x squared plus 2xh plus h squared with the negative outside. Now, folks might ask me, what if that h squared at the beginning was positive? If you factor a negative out of a positive, you're going to leave a negative. So that's a situation that actually involves, quote, factoring out the negative. And once again, you might see situations that require you to factor out the negative. And that concludes this short video about factoring out the common factor.